Hello there, fifth graders, and fourth graders. Whoops. I'm so used to saying fifth graders. Hello there, fourth graders, and welcome to your next math lesson. Please open up your math notebook, open up to the next available page. Today's math lesson is called Find the Unknown, so please write that at the top. Find the unknown. Now, before we get into finding the unknown, there's something I want to talk about called fact families. And a fact family is a group of 3 digits that go with each other, that go together in 4 different problems using 2 different operations. And you can do this with addition and subtraction, and you can also do it with multiplication and division. Today we're going to do it with addition and subtraction. So here's an example. 7 plus 3 equals 10. So we have 3 numbers there, 7, 3, and 10. And we have those 3 numbers together in an addition sentence. Well, if it's true that 7 plus 3 equals 10, we can also make another addition sentence, because if that's true, it's also true that 3 plus 7 equals 10. And you already know that. That's the commutative property, that you can change the order of numbers being added and it doesn't change the sum. But there's also 2 subtraction problems that are true if these 2 addition problems are true. If it's true that 7 plus 3 equals 10 and that 3 plus 7 equals 10, it also has to be true that 10 minus 7 equals 3. And if that's true, it also has to be true that 10 minus 3 equals 7. Now there's a pattern here, and I want you to see this pattern, so I'm going to do some highlighting in some different colors. Sorry, I should have had these highlighters ready, but I didn't. And I don't actually have my colors ready, so scratch that. We're not going to use different colors. Okay, so what I want you to see is that when you're doing fact families, the answer to both addition problems stays in the same spot. And the 2 addends flip-flop. But then when you switch to subtraction, whatever that answer to the addition problem is, whatever the sum is, it becomes the minuend for both of the subtraction problems. So the number that's all the way on the right in both of the addition problems goes all the way to the left for both of the subtraction problems. And the same 2 numbers that flip-flopped as the addend, as the addends in the addition problem, those same 2 numbers flip-flop as the subtrahend and the difference in the 2 subtraction problems. Now, this pattern is so reliable and it's always the same, it's so much always the same, that we can make this pattern even if we don't even have any real numbers. So you learned this chapter that a variable is when we have a letter or symbol representing an unknown number in a problem. We can show this same pattern even if we only have variables. So let's say instead of 7 plus 3 equals 10, let's say it was A plus B equals C. Those are all variables. We don't even know what the numbers are, but we can still make a fact family. If it's true that A plus B equals C, try to think of what would the next fact be if we were using this same pattern. 7 plus 3 equals 10, 3 plus 7 equals 10. If we apply that same pattern here, notice the answer stays in the same spot. So here the C would stay in the same spot. B plus A equals C. Now try to apply that same pattern, the same pattern we used over here. Try to apply it to the 2 subtraction problems using only the variables. Notice that the answer, the 10, which is all the way to the right in the addition problems because it's the answer, it goes all the way to the left and becomes the minuend in both subtraction problems. So here that's the C. C minus A equals B, and if that's true, C minus B equals A. Now why am I showing you this pattern with fact families? Because once you know this fact family pattern, that the answer to the addition problem stays in the same spot for both of the addition facts, and that same number goes all the way to the left of the problem and becomes the minuend for both of the subtraction problems, and the same 2 numbers that flip-flop as the addends in the 2 addition problem flip-flop as the subtrahend and the difference in the 2 subtraction problems. Once you see that pattern, it becomes really easy to find the unknown. Let's take this pattern and apply it to a few unknown problems. Let's say we have 7 plus k equals 12. And we need to find out what is that unknown. Now, it might seem kind of hard because you're used to having the unknown be on the right side of the equal sign. You're used to problems like 5 plus 8 equals blank, and you're supposed to find that it's 13. But you're not used to having the unknown be in the middle of the problem like that. So, the best way to find that unknown is to get it on the other side of the equal sign, and the best way to do that is with fact families. So, apply this pattern here. What would be the next fact in this fact family? Well, when you're adding, the answer stays in the same spot. So 12 stays in the same spot. And what switches places? The 7 and the k. So if it's true that 7 plus k equals 12, it's also true that k plus 7 equals 12. Now that doesn't really help us because the k is still not on the right side of the equal sign. Okay, now let's do the two subtraction problems. Notice the pattern. Whatever the answer is goes all the way to the left for both subtraction problems. So 12 goes all the way to the left for both of the subtraction problems because it's the answer in both of the addition problems. And then the same two numbers that flip-flop over here, the 7 and the k, they flip-flop here and here. So if it's true that 12 minus k equals 7, it's also true that 12 minus 7 equals k. And now we have the unknown on the right side of the equal sign. In order to find out what this k is, all we have to do is 12 minus 7. And so what's 12 minus 7? 12 minus 7 is 5, so k equals 5. Okay, let's do a couple more. Let's do it with subtraction this time. Let's say we have p minus 8 equals 4. P minus 8 equals 4. And we need to find out what p is. Again, it's hard because we're used to having the unknown be on the right side of the equal sign, but all we have to do is use fact families. And we can apply this same pattern. Okay? We know that for both subtraction problems, the minuend stays in the same spot, and this unknown is the minuend. So the second subtraction fact in this fact family will be p minus 4 equals 8. And then whatever that unknown is on the left in the two subtraction problems, it goes all the way to the right and becomes the answer in both of the addition problems. So this minuend becomes the sum in both of the addition problems. And the same two numbers always flip-flop. The 8 and the 4 are the numbers that flip-flop. So 8 plus 4 equals p, and 4 plus 8 equals p. And now we can use either of these facts, because 8 plus 4 and 4 plus 8 really mean the same thing. You know 8 plus 4 and 4 plus 8 are both 12. So p equals 12. So 12 minus 8 equals 4. Let's do another example with subtraction. This time, instead of having the minuend be missing, let's have the subtrahend be missing. Now pay close attention because the subtraction unknown questions are the ones that people get wrong most of the time. Let's say we have 16 minus, we'll say x this time, equals 7. 16 minus x equals 7. Okay, if that's true, what would the next true fact be using fact families? 16 minus 7 equals x. Because remember, when you're subtracting, the minuend stays in the same spot. And then if that's true, 7 plus x equals 16. And if that's true, x plus 7 equals 16. See that pattern? Whatever number is all the way to the left when you're subtracting, it goes all the way to the right when you're adding. And there's only two numbers left, and those are the numbers that switch spots. So which of these facts helps us? Well, it's this one, because that's the one where the unknown is on the right side of the equal sign. So now you just have to do 16 minus 7. So you do 16 minus 7 on the side, and maybe you can do it in your head. And you don't borrow, because if you borrow, then you just get 16 minus 7 again. But you know 14 minus 7 is 7, so you just add 2 to that, and you get 9. So x equals 9. Okay? So that's how you use fact families to find the unknown. I want to do a couple more things with you before this video is over, and I want to show you how to do it with really big numbers. It might seem more confusing, but it's really not if you just use fact families. Let's do 32,527 minus, let's do the unknown, n, equals 18,642. I'm just kind of making up these numbers as I go. How do you know what problem to do to find that unknown? Well, all you have to do is use fact families. Remember, the minuend, the number all the way to the left when you're subtracting, it stays in the same spot. So if it's true that 32,527 minus n equals 18,642, it's also true that 32,527 minus 18,642 equals n. And we just got the unknown on the right side of the equal sign. There isn't even any reason to make the two addition facts. Make the fact families as soon as you write a fact that has the unknown on the right side of the equal sign. That's the problem you need to do. So what do we do to solve for n? We do 32,527 minus 18,642. So 7 minus 2 is 5. We can't do 2 minus 4, so we borrow from the 5, and we make it a 4, making this 2 a 12. 12 minus 4 is 8. We can't do 4 minus 6, so we borrow from the 2, make it a 1, making this 4 a 14. 14 minus 6 is 8. We can't do 1 minus 8, so we borrow from the 3, make it a 2, making the 1 an 11. 11 minus 8 is 3, and 2 minus 1 is 1. So that's the answer. N equals 13,885. Let's do another one with big numbers, but this time we'll have it be subtraction again, but we'll make the missing number be the minuend instead of the subtrahend. Let's do Q. I think this is the kind of unknown that people get wrong the most. This one and division, where the dividend's missing. Let's go ahead and do Q minus 12,678 equals, I don't know, 8,031. I'm just kind of making up numbers here. Okay, it might seem hard to find out what that Q is, but it's really not if you use fact families. Remember the pattern. In fact, I'm going to draw the pattern again. Let's say it's, now, it can be different letters every time. It doesn't always have to be the same letters. It's just the pattern always stays the same. So A minus B equals C. If that's true, A minus C equals B. If that's true, B plus C equals A. And if that's true, C plus B equals A. Once you see that pattern, this number stays on the left, then it goes all the way to the right. In both of the subtraction problems, the number that's all the way to the left is the same number that's all the way to the right in both of the addition problems. Then there's just two numbers left, and they flip-flop each time. So once you see that pattern, this becomes really easy. So all we have to do is apply that pattern here. The Q stays in the same spot for both. I wrote an equal sign there instead of a subtraction sign. Let's get rid of that top part of it so it's actually subtraction. So it's Q minus 12,678 equals 8,031. The Q stays in the same spot. These two numbers flip-flop. 8,031 equals 12,678. The Q didn't even move, so that didn't help us. But now, whatever that minuend is in the subtraction problem, it goes all the way to the right for both addition problems. So we only need to write one of the two addition problems. If that's true, it also has to be true that 8,031 plus 12,678 equals Q. And there's no need to write the other addition problem because we already have the Q on the right side of the equal sign. So it's 12,678 plus 8,031. We add those two numbers together and we have the unknown. 8 plus 1 is 9. 7 plus 3 is 10. We carry the 1. 1 plus 6 is 7. 8 plus 2 is 10. We carry the 1, and 1 plus 1 is 2. And it's 20,709. Now, that is Q. Q equals 20,709. So I showed you in this lesson how to find the unknown using the pattern that's in fact families. And, you know, if this lesson made sense to you, that's great. If it didn't make sense to you, I don't want you to get overwhelmed, because you're going to be working on this. This is the beginning of 4th grade. You're going to be working on this for the rest of 4th grade. We're going to be throwing these kind of problems in throughout the entire year during class time. Also, you're going to be doing these throughout all of 5th grade too. So don't think of this as something that, if you didn't understand it today, don't think that it's the end of the world. It's not. You have 2 years, you know, to get this down. And even after that, you're still working on Find the Unknown for 6th grade, 7th grade, 8th grade, and even on past that. So if you understood this, great. If not, I'm there to help you one-on-one in class. You can raise your hand and ask for help. You can also rewatch this video anytime you want. So just don't let yourself feel overwhelmed if this lesson didn't make perfect sense. And do your best on the quiz attached below. But if this didn't make sense, then maybe hold off on doing the quiz until you can get some one-on-one help, okay? And I will catch you. Oh, you know what? I'm going to give you some independent work here. Okay, by yourself, independently, and I'm going to make these pretty easy. K minus 35 equals 12. Solve for K. Q minus 16 equals 26. Solve for Q. We'll do one more. B plus 24 equals 73. Go ahead and solve for K, Q, and B independently, and then click on the video attached beneath this video to see if you did those correctly. I will see you there. Mr. Dauber, for now, signing off.